In example 2 here, we have a quadrinomial. We have 4 terms, 1, 2, 3, 4. We have a cubic because we have to the third power. So here's an example that's larger than that x squared again. And we want to solve this. So we know when solving, we want to get things set equal to 0. That's normally our best bet. And so if we get this set equal to 0, even if you're not sure what to do from there, start by getting it set equal to 0. X to the third minus 3x squared plus 3x minus 9 equals 0. Okay, now there's not a common factor between all the terms because they do not all have an x value. The 9 does not have an x with it over here. Okay. So what we can use on this one is a review of factoring by grouping. So if you have 4 terms, that's a really good sign that you'll be able to do factoring by grouping. So watch for that. If you're not sure what to do, look and see if you have 4 terms, and this is the way to go. So when you factor by grouping, you do 2 sets of parentheses. You group the first 2 terms and then the second 2 terms together, and then you factor out the GCF of each set. So let's go ahead and do that on our example. So I'm going to group the first 2, and I'm going to group the second 2. And notice how I'm including this sign here, that positive 3. It is important that we consider that as we go. So now if I look at my first set of parentheses, only looking at these first 2 terms, only looking here, I can divide these both by an x squared. So we can factor out an x squared between those 2 terms, and then we'll go ahead and actually do that. So if we factor out x squared from each term, we'll be left with x to the third divided by x squared. Remember, we subtract, so 3 minus 2 is just an x, and then minus 3, and then the x squareds here completely cancel out. So there's my first set of factoring. Now I'm going to go to my second set of parentheses, and I'm going to do that same thing. I'm only going to look at these 2, and I'm going to look at whatever the sign is. Whatever sign comes here, that's the sign that we're going to factor out. So I can divide both of these by 3, and I'm going to divide them both by a positive 3. So whatever this sign is here is really important. That tells us if we're going to factor out a positive or a negative. So we're going to factor out a positive 3. And if we do that here, 3 divided by 3 is 1, so we're left with x. And then negative 9 divided by positive 3 is a negative 3. Now what you should notice, and hopefully this looks familiar, you should have the same binomial inside those parentheses, because then we have one more GCF step we can take. Both terms, right? Because in this case, this is one term because they're multiplied together. This is one term because they're multiplied together. And both of those terms have an x minus 3. That's the greatest common factor between those 2 terms. So I can factor out the x minus 3. Okay. And if I factor that out, then it's gone in the first term and I'm left with the x squared. And it's gone in the second term and I'm left with the positive 3. So there's my completed factoring by grouping. So if you have 4 terms, there's no terms that you can combine, there's no greatest common factor, factoring by grouping is what you'll want to do. All right, here's another example. Now in this case, it's already set equal to 0, so that's great. We got a good start there. We have x to the 4th power. Okay. We have 3 terms. Okay. So when we have 3 terms, normally we want to look for a greatest common factor. And there's not one here. They don't all have x, and I can't, if the lowest coefficient's 1, there's nothing else I can factor out. So the other thing to look for with 3 terms is if you can factor into 2 sets of parentheses. And we've talked about this with our x squareds, with our quadratics. But in this case, we can still go ahead and do that. So I'm going to go ahead and do my 2 sets of parentheses equals 0. We just have to consider what we have. We have an x to the 4th. So to get x to the 4th, instead of just taking x times x like we normally would, we have to do x squared times x squared. And then I want to multiply to a positive 2, but then add those together to get a negative 3. So I want to do the only numbers that multiply to 2 are 2 times 1. So I have to do 2 times 1. And to get -3, they both have to be negative. And then if I check that, I know a negative times a negative is that +2 that we're looking for. And we can do a quick check in the middle and the outside. So this will give me -1x squared. This will give me -2x squared. And if I combine those, that's -3x squared. And that is my middle term. So it's okay if you don't have just an x squared here in the first term. If you have 3 terms, you can still piece it apart and factor it into 2 sets of parentheses. And then of course from here, because the directions are to solve, we're not done yet, our equation is set equal to 0, so we can take each set of parentheses here and set them equal to 0. So x squared minus 1 equals 0, x squared minus 2 equals 0. So this will give us square root of 1, and we want to do plus or minus. Because this is a squared, I should get 2 answers. So my 2 answers come from a positive and a negative, and the square root of 1 is 1. So positive or -1 are 2 of the answers. And then if I jump over here and solve the other one, again, we're going to get 2 because we have x squared. And this time we'll get plus or minus the square root of 2, so we're just going to leave that root 2 as our other answer. So just because we have a larger exponent doesn't mean we can't factor into our 2 sets of parentheses.